Welcome to the Bosch Virtual Driving Center. Today I'll introduce you to the Business Division Gasoline Systems. At the heart of our work is the generation of engine power and the transfer of power via the transmission to the wheels. Our know-how encompasses the entire drivetrain of an automobile. That includes the fuel supply, intake air management, the fuel injection, and ignition. In addition, the whole of engine management, transmission control, and finally, exhaust gas aftertreatment. Gasoline systems know-how can be applied to gasoline engines with manifold and with direct injection, as well as to flex fuel and hybrid engines. Our engineers work together with automobile manufacturers to develop solutions for new performance standards and technology. We apply our systems in the vehicle, developing them through to serial production. So let's have a look and see just where in a vehicle our know-how can be found. Let's use a gasoline direct fuel injection model to follow the path the fuel takes from the tank to ignition. The in-tank unit, known as accelerated Bosch, is a module that delivers the fuel from the tank to the high-pressure pump of the engine. It requires only minor modifications to be adapted to any vehicle. Let's take a closer look. Oh boy, dark in here. Oh no, my good shoes. Our fuel filters allow no particles larger than 5/1000th of a millimeter to pass. Not even a strand of my hair would get through. Unless, of course, I modify myself. The high-pressure pump increases the delivery pressure in the system created by Accelerate many times over, raising it in some cases to 20 megapascal or 200 bar. And that means serious power. The fuel rail distributes the fuel to the high-pressure injection valves. These injectors with multi-orifice technology enable high precision, the tiniest fuel droplets, and a variable spray configuration for optimal combustion to be achieved. Wow! Quite a fiery temperament. But in addition to fuel, an engine also needs air for combustion. With our products, we offer comprehensive intake air management. Let's take a detailed look at the individual components. Here at the entrance to the manifold, which is made of either plastic or metal according to customer preference, you'll find our throttle device. To reduce the smallest adjustable airflow setting still further, we've optimized the geometry of the throttle. Whoa, that's a major draft in there. With its special geometry, the manifold influences the charge cycle processes, which give the engine its respective performance characteristics. Let's accompany the air on its way to the combustion chamber. Here we find the swirl control valves. They influence the passage of air into the combustion chamber and create a targeted swirl effect for the best possible combustion. Wow, that's fun! Oh, excuse me. The air supply is a significant determining factor for the quality of combustion. The air mass must correspond to the fuel mass. Its movement must be coordinated with the form of the stream of injected fuel to ensure the ideal spread of the flame front in the combustion chamber. Oh! All right, folks, that's enough. Just look at me, a total disaster. You won't get me back in there again.
Roberta, we're on air.
Oh, beg your pardon. The mixture formation is an important factor for exhaust gas treatment in the catalytic converter. With the help of the lambda sensor, it's regulated to enable the three-way catalytic converter to achieve its maximum treatment performance. A convertible would be great right now. Driving pleasure with low emissions. You've just seen systems that make a contribution to economical and clean combustion. They provide the exact dosage, processing, and distribution of air and fuel for each individual combustion cycle, and of course exhaust gas aftertreatment. all of which is regulated by our engine control unit. Let's take a closer look at the unassuming little box. We're here in the computer center, headquarters of engine management. I'll demonstrate its performance capability using the example of direct start, with which a fuel-saving stop-start function can be realized. Our engine control unit, here the DI Motronic, detects when the vehicle has come to a halt and cuts off the engine. A speed sensor constantly measures the crankshaft angle and transmits the data to the control unit. Based on this angle, the DI Motronic discerns the shutoff position of the individual cylinders. It selects the one suitable for the direct start and calculates the actions necessary for the direct start. As soon as the driver wishes to move off, DI Motronic instructs the starter and the fuel injection system. Fuel is injected, ignition, the engine starts. Turbocharged engines with gasoline direct fuel injection let the DI Motronic show its full performance capability. The interplay of fuel injection, exhaust gas turbocharging, and camshaft timing control or scavenging calls for high-performance engine management. The investment pays off. The once typical disadvantages such as higher peak consumption and turbo lag are history. That makes driving a lot more fun. But just generating the power isn't enough. It must also be efficiently distributed to the wheels. In our business unit's continuously variable transmission and transmission control, we develop components, modules, and software to ensure optimal delivery of the power to the roads. Continuously variable transmissions have great advantages for urban traffic. No gear shifting and coupling, more driving comfort, and lower fuel consumption, thus less CO2 output. Automatic transmissions can be adapted with software to meet a wide variety of demands. Our electronic transmission control recognizes the current gear status, the driving situation and style, and reacts accordingly, for example with optimized shifting points. And that means more driving dynamics and comfort. BOSCH Gasoline Systems helps automobile manufacturers worldwide to further improve the functions of the entire engine system for higher performance, lower emissions, and reduced consumption with correspondingly less CO2 output. Of course, we also develop systems for environmentally friendly natural gas engines, for example the engine control unit, NG Motronic, and valves and rails developed especially for gas engines, which conform to the stringent OEM requirements and form the technological basis of future hydrogen applications. Components for alternative engine systems are undergoing intensive testing in our development centers worldwide to speed their way to serial production in the highest quality. Hybrid engines will play an increasingly important role in the future. Our engineers have worked successfully for many years on the integration of the combustion engine and the electric drive. Our ambition is to keep on making vehicles better so that you can be a cleaner, more economical driver and more at ease on the road. We achieve this ambition with a comprehensive program for the entire drivetrain, drawing on a wealth of know-how to serve our customers with the greatest competence and individual care. With our services, we help automobile manufacturers to adapt systems individually to their vehicles. Together, we always find the right solution.
Roberta, we'll have to do the scene with you in the combustion chamber again. Sorry.
No way, guys. Count me out.
Roberta!
BOSCH, invented for life.